Okay, a photovoltaic square cell of 1 centimeter squared is placed in a position where the intensity of sun is 1,000 watts per square meter, right? And the hardest part of this problem is to realize that a square centimeter is actually 1/10,000th, right? It's a meter is 100 centimeters by 100 centimeters, right? Right? So that's 10,000 square centimeters, right? So therefore, a square centimeter is 1/10,000th, right? So 1 divided by 10 is 1 times 10 to the 4th square meters, right? So my area is 1 times 10 to the minus 4th square meters, right? So if it's 1,000 watts per square meter, right, then the power incident on that area, the power available to be absorbed, right, is going to be 1,000 watts per square meter. Right? This is like a calculator, right? The little solar cells on a calculator times 1 times 10 to the minus 4th, and that's square meters, right? So that times is 0.1, right? And that 0.1 is that's watts, right? So if it's 15% efficient, what is the power absorbed? Well, that's going to be 0.15 times 0.1 watts, right? So I'm going to multiply that by 0.15, and I get 0.015 watts. And the answer at the bottom doesn't say that. Oh, it really should say that. Okay, so that's a typo. Okay, so get rid of that one there, right? So the power absorbed is 0.015 watts. Okay. If the potential difference across a cell is 0.5 volts, how much current is produced? Well, power P is IV, right? Right? So I is P over V. Right? Okay, so that's 0.015 volts divided by 0.5. I'm sorry, watts. I think I know a watt divided by 0.5 volts. Okay, storage A divided by 0.5. And that's 0.03 amps. Okay, if 10 of these cells are placed in series, what would the total difference be? Well, when you place them in series, they just add V plus V plus V, right? So 10 times a half a volt, right? 10 times 0.5 volts, right, is equal to 5 volts. Yeah, that's our answer there, right? If 10 were placed in parallel, what would the current be? Well, if you place them in parallel, that's like this, right? Etc., right? Then the current is, of course, it's a parallel circuit, so the current adds up, right? Do 10 of those, right? The current would be 10 times this, right? So the current would be 0.3 amps, right? 10 times 0.03. And then it says, how many of these cells would you need to produce 100 watts? Well, each cell is 15% efficient. What is the power absorbed? I think power produced is the word that we're trying to say here, right? What does it say? The potential. It says power absorbed in the problem. Okay, well, there you go. Okay, the power absorbed is 0.1 watts. The power produced, so I think that's a typo in the problem, right, is 0.15 watts. Okay, so how many do you need to produce 100 watts? So the question is, how many of these are there in 100 watts, right? So 100 watts divided by 0.015 watts per cell, right, is 6
6, 6, 6. It's 6, 6, 6, 6, 6, 6, 6, 6.
Oh, it just repeats. Yeah, there we go.